Hey guys, welcome back. Have you ever been in a situation where you are trying to optimize a slow running query to make it run faster? You have been looking at this query for hours and realize that the query is scanning the entire table. And you are thinking, gosh, this query will be super fast if it only targets specific set of records instead of the entire table. What you really want in such cases is partitions. In this lesson, we are going to learn about partitions in Hive. First, we'll talk about what are partitions, and next, we'll go into benefits of partitions. And third, we'll talk about creating and loading partitions in Hive. Fourth, we'll talk about dynamic partitions. And finally, we'll also look at the benefits of dynamic partitions. Sounds good? Are you guys excited? Let's get started. Let's say you want to query the stocks table to look at the stocks details for symbol XYZ for the date July 3rd for year 2000. Even though as a user you're only interested in one stock symbol for a specific date. This query, however, will run a MapReduce job and the job will scan the entire data set to get you the result set. This means that the execution time will be longer. Wouldn't it be so nice if we can target the query to scan only the records that belong to the symbol XYZ to get the result set? There is a way to do exactly that in Hive, and it is by using partitions. Sounds interesting, right? Okay. Right now, the stocks table has no way of differentiating the records for symbol XYZ with records for symbol, for instance, ABC. Using partitions in Hive, you can basically compartmentalize your dataset. Let's see this in action. The syntax for creating a partition table is very similar to a regular table. The only difference is the partition table will have the partition by clause, and you have to mention a new name to the partition column. In the stocks_partition table, we are naming the partition column as SYM. As I want to partition the dataset by symbol, please note that this column is not the same column as the symbol column in your table. So let's create this table now. I'm logged into Hive. Let me switch the database. There you go. The table is now created. Let's execute the describe command on the table and you will see the information about the partition. Describe formatted stocks_partition. Copy that. There you go. As you can see now, the describe information for this table shows partition information. The column name for your partition is SYM and the data type of that is string. Let's now look at how to load data into the partition table. It is slightly different from loading a regular table. Let's look at the insert. I'm selecting all the records from the stocks table with simple B7J and inserting those records into the stocks_partition table. Important thing to note here is that you're assigning B7J to be the value of the partition column SYM. Let's execute this query. Let's wait for the execution to complete. The execution is now complete. As you can see, Hive created a partition in stocks_partition table with the name SYM equals B7J. Let's now create another partition for symbol BB3. This time I'm selecting the BB3 records for stocks table and I'm assigning BB3 to be the value of the partition column SYM. Let's execute this insert. There you go. Again, a MapReduce job is running and this will create a partition with name BB3. There you go. The execution is now complete and you can see another partition that got created with the name BB3. If you want to list the partitions for a given table, just say show partitions and the table name. So copy this and execute in the cluster. There it is. As you can see, there are two partitions. Now, I would like to show you how the data is physically structured for this table stocks_partition in HDFS. Let's first execute the describe formatted on stocks_partition to get the value from the location attribute. So here is where the data for this table is being stored in HDFS. So let's copy this and let's do a Hadoop FSLS on this location. Usually you will see files under the tables directory, but the partition tables are structured and stored slightly differently. As you can see, under the directory stocks underscore partitions, we see two more directories, one for symbol B7J and the other one for symbol BB3. Any idea why we see two directories? These are partition directories. Let's check the directory B7J now. As you can see, you see a file under B7J, and this file will have just the records for symbol B7J, nicely stored in the partition directory. Now when you query the data for symbol B7J using the partition column SYM, like this right here, the MapReduce job will only scan this specific directory. And that is quite powerful. Since we are not scanning the entire dataset anymore, the execution time of this query will be much faster. We can also load a partition from a HDFS location. Let's say the records for symbol ZUU is in the directory output hive stocks-ZUU, which you can load by using this insert. We are simply selecting all the records from the stocks where symbol equals ZUU and writing the output under output hive stocks-ZUU directory. Let's execute this insert in our cluster. So this insert will create this output directory stocks-ZUU, and it will select all the records from the stocks table with symbol ZUU and will insert all the records into the newly created directory. There you go, the execution is now complete. Now that the directory is loaded with ZUU data, we can add a partition to the table using the alter command like this right here. So in this instruction, you're saying alter table stocks underscore partition, add the partition SYM equals ZZU, and you're also giving the location from where you can load the partition. And for the location, you're specifying output hive stocks-EUU, where you have already loaded the records for ZUU symbol. So let's execute this alter. Oops, the directory was specified wrong. The output directory is not under the root directory, so let's fix that. So let's copy it again. Execute it. The partition is now created for symbol ZUU. Let's do a show partitions again to see the list of partitions for the table now. As we can see, we have created 3 partitions so far. One for symbol B7J, second for symbol BB3, and finally for symbol ZUU. You can also create multiple partitions with one insert and multiple selects like this. So this instruction is very simple to understand, but it also looks a little weird. So look at it. So first you're saying from stocks S, you're starting with the table name, and then you have an insert followed by a select. You have another insert followed by a select. Here you'll be creating 2 partitions, one for symbol GEL and the other one for symbol GEK. For both partitions, you'll be selecting appropriate records from the stocks table. So let's execute this query. Let's wait for the execution to complete, and once it is complete, we'll do the show partitions command again. The execution is now complete. Let's now execute the show partitions on the table to check out the newly created partitions. There you go. We see the newly created partitions GEK and GEL. Remember, you cannot delete records from a Hive table, but with partition tables, you can drop partitions using the drop command, which will essentially result in deleting all the records for that partition. Let's say, for instance, you want to delete all the records for symbol GEL. Usually, you will not be able to do that using Hive as you would do with the delete statement in SQL. But with the help of partition, you can drop the entire partition. And here, you're essentially dropping the partition GEL, which has all the records for symbol GEL. So let's copy this and let's do a drop for symbol GEL. This will delete the partition GEL. So let's do a show partition again. There you go. The partition GEL is now gone. Take a look at this insert. In this insert, we are loading records for Microsoft into Apple partition. This is logically wrong, since it will return Microsoft records when a user queried the Apple partition. Hive will not validate the data that is loaded into partitions. And also, it will not raise any errors when you incorrectly load data into partitions. It is the developer's responsibility to make sure the partition is loaded with correct set of records. So let's summarize what we have seen so far. So far, we looked at what are partitions, we also saw the benefits of partitions, and we also saw how to create and load partitions. Now we are going to talk about dynamic partitions. Imagine you are trying to create partitions for thousands of symbols. Manually creating partitions one by one is a tedious exercise, and also will eventually lead to errors like the one we just saw with Apple and Microsoft. Dynamic partition inserts solve that problem. So far, we have been giving the values for the partition columns, and this means that the values for the partition columns are known at compile time. When you use dynamic partition inserts, however, the partition column values are known at execution time. Let's see this in action. Let's first enable the dynamic partition by setting Hive exec dynamic partition equals true. The dynamic partition is now enabled. Take a look at this query. In this query, you're not hard coding symbols anymore. At runtime, the symbols will be resolved, and for each symbol in the stocks table, a partition will be created and all the records for that symbol will be loaded into the appropriate partition. That's pretty easy, right? Let's execute it. This will give you an exception. By default, Hive exec dynamic partition mode parameter is set to strict. So in strict mode, you would need to have at least one partition column to be given a static value. This is to avoid careless errors by dynamically loading the partitions with, for instance, your date column. Since we'll end up with many number of partitions, one for each date in the dataset. That is bad, right? Since we have only one partition column, we cannot load this table in strict mode. We can change the Hive exec dynamic partition mode parameter to non-strict mode, but then we will leave the table vulnerable to errors. So I like to keep the mode as strict. Let's create another table, and this time we'll create the table with 3 partition columns: exchange name, year, and symbol. Let's create this table. The name of the table is stocks dynamic partition with 3 partition columns: exchange name, year, and symbol, and it is now created. Let's run a describe on this table. And as you can see, you have 3 partition columns. Let's now see how to dynamically create partition for this table. Look at this insert. We are giving a static value of ABCSC for the first partition column exchange name. Look at the select statement. The dynamic partition column must be specified last and in the same order in which they appear in the partition clause. As you can see, we have given a static value for the first partition column. The value for the next 2 columns will be derived from the select statement. Technically, this query should execute, but Hive is known to have stability issues when we try to create dynamic partitions with huge dataset. I've included a link that talks about this issue in the lesson notes. The later versions of Hive will fix this issue. So to avoid this issue, let's create partitions for records from 2001 to 2003 with this insert right here. Uh-oh, we see an error. Let's see what the error is. The error you're seeing here means that the number of partitions that you're trying to create is more than the number of partitions that is allowed per node, which is by default set to 100, which is very low. But we can configure the number using 2 properties. The first property, Hive exec max dynamic partition, will tell you how many partitions in total are allowed to be created. The second property, Hive exec max dynamic partitions per node, will tell you how many partitions are allowed per node. So I'm going to set the first property to 1000 and the second property to 500. So let's go ahead and set these 2 properties. There you go. The property is now set. Even now, when you're trying to run this insert, Hive will give you an error because our cluster is not a huge cluster, and when Hive is trying to calculate the space required to create all the necessary partitions, it will not find enough space in the cluster. So I'm going to even restrict the number of partitions that I'm going to create using another condition in the where clause. I'm saying where symbol that starts with B. So this insert now will create partitions for records from year 2001 to 2003 and also for any stock symbol that is beginning with B. So let's run this insert now. The execution is now complete, and as you can see, our dynamic partition insert created a lot of partitions. To be very specific, it created about 362 partitions. Let's execute the show partitions on the table to list all the partitions. There you go, 362 rows, which means 362 partitions created with just one insert. I'm curious to see how the directories are now structured for each partition, since we have more than one partition column in the table. So why don't we do HDFS listing on the table first? Now under this table, we see the high level partition, which is exchange name equals ABCSC. Now let's go into that partition and see what is inside that partition. As expected, there are three partitions under the first partition ABCSC. One for year 2001, 2002, and 2003. Now let's go into 2003 directory. In this directory, we will see several directories or partitions, one for each symbol. The symbol directories will have the files for that corresponding symbol. Let's look at both of these queries. Both queries are valid. In the first one, the MapReduce job targets the 2003 partition and it will process all the records under that directory. The second select is even better, since the MapReduce job will only execute on files under the directory ZUU, which is under the directory 2003. So the execution will be faster than the first query, since we are scanning only fewer files. Now look at this select statement right here. If you try to execute this query, you will see an error, because when the property Hive MapRed mode is set to strict, Hive will not allow to execute a query on a partition table without specifying a partition column in the where clause, because this query is considered risky, since we did not include a partition column in the where clause for filtering, because now Hive has to scan the entire table to fetch the result set. Makes sense, right? Now to make this query work, again, we can set this property to non-strict, but I would advise against that because that would lead to performance issues. So instead, let's fix the query by adding the partition columns in the where condition like this. And this query right here with the where condition exchange name and volume will execute with no issues. Okay, now we have seen what are dynamic partitions, benefits of dynamic partitions, and also we have loaded a table using dynamic partition inserts. Wow, that was a lot to take in. So let me summarize. Partitions minimizes the execution time by helping MapReduce job to execute on targeted files or directories. We also saw a few different ways to load partitions. We also saw how to load hundreds of partitions with just a simple insert select statement using dynamic partitions. Partitions are very powerful. And when you design the tables with right partition columns, it will save a lot of execution time and your queries will be faster. So when you design a Hive table next time around, always think of partitions. With that, we'll end this lesson. See you in the next lesson.